Hi everyone, my name is Angelica Hunt and I'm currently a junior studying civil engineering here at Penn State. Today I'm going to be discussing a relatively newer innovation in the construction industry called geopolymer concrete. This type of concrete has been developed and used to improve sustainability for structures in Australia and reduce greenhouse gas emissions. Since concrete is the most widely used synthetic material in the world, applications of this more sustainable type of concrete have the potential to be used in the construction industry in the future. This presentation focuses on how and why geopolymer and green concrete came to be, applications of geopolymer concrete runways at Brisbane's West Wellcamp Airport in Australia, and some simple life cycle analysis calculations and emission analysis for some types of geopolymer concrete mixtures. So most people know that concrete is a very commonly used construction material in Australia and the rest of the world, but it actually contributes a lot to carbon dioxide emissions worldwide and is a very energy-intensive material to produce. In general, concrete is actually a sustainable building material due to its resource efficiency, durability in construction, and environmental implications. The main resources used in cement and concrete are very abundant on Earth, as limestone can be found almost anywhere, and aggregates are also very common. Additives like fly ash, slag, and silica fume are repurposed waste byproducts from manufacturing plants, so they help to reduce the amount of energy put into concrete. Concrete is also a very durable building material with a long lifespan, meaning that structures containing concrete are more likely to last and not have to be rebuilt often. It also helps to minimize the effects of solar radiation because concrete is usually light-colored and will absorb less heat. In addition, concrete can be broken down and recycled into aggregates to be used in other concrete projects. Because concrete is a good choice for sustainability, there have been efforts to create green forms of concrete to reduce its environmental impact. Geopolymer concrete is one of these forms of green concrete. It uses waste byproducts from manufacturing plants like blast furnace slag and fly ash to reduce or eliminate the amount of Portland cement needed in a concrete batch. Fibercon, a concrete company based out of Queensland, Australia, has developed a concrete using recycled plastics for reinforcement instead of traditional products like steel. The commonality in all these new concrete mixtures is that they use significantly less energy and have lower greenhouse gas emissions for production compared to traditional concrete mixtures. Using plastics and waste products as additives can reduce carbon dioxide emissions by up to 50%. The cement industry in Australia produces more than 10 million tons of cement-related materials per year, which releases about 7.2 million tons of greenhouse gases annually. And considering that the Australian population is increasing and there is a need for new houses, the demand for concrete isn't decreasing anytime soon. A company called Wagner's, based in Australia, has recently developed an earth-friendly concrete that uses geopolymers like blast furnace slag and fly ash to completely replace the Portland cement component of concrete. This earth-friendly concrete mix was used to construct the runways at the Brisbane West Wellcamp Airport. This was Australia's first green public airport, built in 48 years when it opened in November of 2014. The 70,000-ton airway pavement project lasted from April 2013 to November 2014 and was estimated to cost about $150 million. For this project, the Wagner concrete mix was estimated to have saved more than 6,600 tons of carbon emissions. Because it was so successful, the Brisbane Airport concrete project won a Sustainability Excellence Award from the Concrete Institute of Australia. Using alternatives to Portland cement can have significant effects on the amount of carbon dioxide emitted into the atmosphere. The graph on the screen shows the carbon footprint intensity of two different types of concrete mixtures in two different studies. One mixture consists of 100% original Portland cement. One is 30% fly ash and 70% Portland cement, and the last contains 30% blast furnace slag and 70% Portland cement. This life cycle assessment reveals that the ordinary Portland cement mixture tested has higher greenhouse gas emissions than all of the other concrete types tested. These results are only from Australia, so there's currently a lack of data from other countries testing the geopolymer concretes. However, this data can still be used to help inform the cement and concrete industries in forming strategies for reducing future greenhouse gas emissions. The demand for concrete production in the construction industry is not going to be decreasing in Australia or anywhere in the world anytime soon. With global warming and climate change in mind, it is important to consider reducing emissions in concrete because it contributes a significant 8% to global carbon dioxide emissions. Of course, more research needs to be done to fully understand the impacts of using geopolymer concrete, but at the moment it seems to have a lot of potential for the future of the construction industry. Thank you.